Okay, so you're on the freeway, going at a decent speed, and then all of a sudden, you slow down and find yourself in a queue. You think, okay, maybe there's an accident up ahead, and then a moment later, the queue is gone, and you're at free flow speed again. What just happened? Why did everyone stop and then go again? Well, you've just been in a phantom traffic jam, or more accurately, a shockwave. In this video, we're going to discuss traffic shockwaves. What are they? What causes shockwaves? And what are the potential solutions to this? A phantom traffic jam. Sounds so ominous, like an evil spirit living on the road. The technical term for this is a shockwave. And no, I'm not talking about what hits you when a bomb goes off. If you can imagine a traffic stream to that of a literal flowing body of water, if you suddenly dam it up, you'll get waves bouncing back upstream. These are shockwaves. For traffic flow, this concept is very much the same. We have a certain number of vehicles flowing with the very close following distances. If the car at the front stops for a moment and goes again, this impacts everyone behind in a similar fashion, except the stopping location moves upstream along with the traffic flow, just like the wave in water. To demonstrate this, I'm going to create various scenarios. One is with a signalized intersection, and then the other is on a freeway where vehicles stop, slow down, or change lanes aggressively and cause shockwaves in the traffic stream. Okay, so this is a normal signalized intersection, and for one approach we can see a very high traffic demand, stopping at the red light and forming a queue. Watch what happens when the signal goes green again. The front of the queue dissipates, but the back of the queue is still forming. This right here is the shockwave. And here we can see it again. Once the signal goes red, the queue develops, and the signal goes green again, but the queue wave still moves upstream. Next up is a stretch of freeway, and we can see that with vehicles suddenly stopping or slowing down because there's an accident on the side of the road, a small queue is formed. And while the vehicles at the front of the queue can carry on without much issue, they have just caused a shockwave that travels upstream along the freeway. This also applies to vehicles cutting in front of others and causing vehicles to slow down. So, now that we know what traffic shockwaves are and how they impact the road network, how do we solve this problem? Well, the first obvious answer to that is to have everyone drive better, maintain safe following distances, change to your preferred lane early and not leave it for the last moment, only change lanes when it's safe to do so and not cause others to slow down or stop for you to merge. But this solution requires everyone to be on their best behavior and is not always achievable. So we have to look elsewhere. Other solutions fall in the ITS category, Intelligent Transport Systems. And within this category is a solution called VSLS, Variable Speed Limit Signage. This is a technological solution that changes the speed limit of a stretch of road dynamically and is typically enforced when there is an accident or severe congestion up ahead. Reducing the speed limit will reduce the arrival rate of vehicles and thereby the significance of any queuing and development of shockwaves along the freeway. This is also an incredibly powerful traffic safety measure, because for someone who is traveling at high speed along the freeway to suddenly stop because of this queue is asking for trouble, especially if it is a heavy vehicle with a lot of momentum. This is to some extent one of the benefits of ramp metering on a freeway. Too many vehicles joining the freeway on the on-ramp can cause vehicles already on the freeway to slow down drastically and cause this traffic shockwave. Similarly, at traffic signals, increasing the amber time from 3 to 4 seconds prompts vehicles up ahead to start slowing down. Combining this with increased green time reduces the chances of shockwaves forming. If this doesn't work, the intersection can always be upgraded or converted to a roundabout. This is also very important in access spacing in intersections, and you can check out my other video on design considerations between roundabouts and signalized intersections for this. One last thing, if you see a queue forming up ahead and you think it might be a phantom traffic jam or shockwave, you can slow down and give everyone else behind you enough time to realize the same thing. If everyone slows down gently instead of stopping, the shockwave perhaps doesn't even form, but if it does, it'll disappear very quickly. If you have an interesting traffic shockwave story, please comment down below. Thanks again for watching. If you've enjoyed the video, give it a like and consider subscribing for more interesting videos. Bye for now.